right, in this video we're going to be doing some notes on solving logarithmic equations. So in order to do that, I'm going to have to use some properties of logarithms. So we've got a little review of the properties up here on the top. So again, the answer to a log is just an exponent. So if I have two logs that have been added together, the rules for exponents say when you multiply two things, you add their exponents. So that means we're the log of the product of x and y if I wanted to condense them together. Addition on the outside can be turned to multiplication on the inside. The opposite of that would be subtraction on the inside or on the outside, sorry. So subtraction on the outside would convert to division on the inside because when I divide two things, I subtract their exponents. Also, when I take a power to a power, I multiply exponents. So if I have a number multiplied by a logarithm, I can bring that up and turn it into an exponent. All right, I need to use those properties in order to condense logarithms when I'm solving equations so that I have fewer logs in the problems I'm dealing with. This next bit here is a flowchart of methods for solving log equations. So when I have a log equation, the first thing I want to do is I want to look at the terms. Do all of the terms have a logarithm? If so, I'm going to use this method here. If some of the terms do not have a log, then I'm going to go with my second method. So the reason I'm saying that this equation, everything has a logarithm, is my first term right here was the log base 3 of 2. Then I had 2 times the log base 3 of x, and then over on the right, I had the log base 3 of 7x minus 3. So every term had a logarithm in it. When that happens, what I want to do is condense so that I have one log on the left and one log on the right. I'm going to get this down into the point where I have the log of something equals the log of something else. So in order to do that, I need to use my log properties. Back to my original equation, the 2 that was out in front of this log could be brought up into the exponent. Then I have 2 logs that have been added that can be condensed into the product of 2 times x squared on the inside. Now I'm down to the point where I have the log of something equals the log of something else. If that's the case, then the insides must be equal. So I have 2x squared equals 7x minus 3. This is just a quadratic equation. To solve quadratic equations, I move everything to one side to get it to equal to 0. So I subtract the 7x and add the 3 to move them over to the left. Then I have to do factoring, ideally. It might turn into something you have to quadratic formula, but factoring is going to be the easiest. So I'm going to go through my method, what 2 things multiply to 6 and add to negative 7. However you like to factor, I work this down into 2 factors, 2x minus 1 and x minus 3. Then to solve, I set each factor equal to 0. So if 2x minus 1 equals 0, I move my 1 over and divide by 2 to get x equals a half. If I have x minus 3 equal to 0, I move the 3 over to get x equals to 3. The last step of verifying that everything works in my log equation is to check. Remember, you can only take the log of a positive number. So it doesn't mean my answers can't be negative, but if I take both of these answers, 1/2 and 3, and put them back into my original equation up here, would I ever have the log of a negative? This was the log of 2, so that's never going to be negative. This is a log of x. Both things I would be checking, the 1/2 and the 3, are both positive, so that would be good. How about if I plug them in here, though? If I plug in a half, 7 times a half minus 3, that's still positive, so that's good. 7 times 3 minus 3, that's still positive, so that's good. And that means both of my answers that I got down here will work. The alternative is that not everything is inside a logarithm. An example of that is over here on the right. My first term has a log base 4. My second term has a log base 4. But over here on the right, I have 3. This 3 doesn't have any logarithm with it. When that happens, I have to condense. I have to get the logs on one side, and the non-logs, everything without a log, has to be on the other side. So for this one, I'm going to condense. 2 logs that have been added can be rewritten as the product of their logs. On the right, the 3 is just a 3 by itself. If there had been other terms without logs, I would combine them with the 3. Now I've got a logarithm. Once I have that, I'm going to convert into exponential form. Remember, when converting into exponential form, the base of the logarithm, which was 4, is going to stay the base. The 3, which used to be by itself, will now be up here in the exponent. And whatever was on the inside is now going to be by itself. So now that I have that, this is really just a quadratic equation. It's kind of in a funny looking form because I'd want to distribute this x to get x squared minus 12x. 4 to the third is 64. Now I have a quadratic, so I can get it equal to 0 by moving everything to the left. And then I factor. I get my two factors. I set them both equal to 0. And I get my solutions. From over here on the left, I get x equals negative 4. This one you can see is crossed out. It's an extraneous solution because if I try to plug negative 4 back into the original problem, it's not going to work. I can't take the log of negative 4. Once I have that it's not going to work there, I don't even bother to plug into the next one. Now I'm going to try the next one. When I solve that, I get x equals 16. Looking back to the original problem, plugging in 16 would be fine for this one. Plugging in 16 would also work here. 16 minus 12 is 4, so that's going to work, and x equals 16 is my only solution. Example 1 here, I'm going to solve the equation. Again, this is a simplified version. I have only something with a log and something without a log. When that happens, I have to remember, for all equations, I can't take the log of a negative, so I just have to be sure when I check my answers, x is going to have to be greater than 0. All right, this was already condensed, so I don't have to worry about condensing anything. I can jump straight into converting forms. My base was 4. The x used to be with the 4, so the x is now going to be on the other side. The 2 used to be by itself, so it will now be the power for 4. 4 squared is 16. I get my solution. I get x equals 16, which is a fine answer to check it because 16 is good inside my logarithm. Switching over onto the back, when I look at this problem, my inside is x cubed, and this inside is just x. So the first thing I want to think about is my domain for my original problem, and x is just going to have to be greater than 0, so I'm not taking the log of a negative number. When I look at this, I want to decide, is everything in a log or just some things? I've got a log, and then not a log. When that happens, I want to condense my logs together. So first thing I need to do is bring that 2 up. So that would now be the log of x squared. My first log, my log base 2 of x cubed, I'm going to leave the same for just a moment. Now I want to put these two logs together. 2 logs subtracted is the log of the quotient. So I can divide the insides. I can reduce that to the log base 2 of x is equal to 6. Now I have condensed. I'm ready to convert the equation into exponential form. My base was 2, so my base stays 2. The 6 used to be by itself, so it's now in the exponent. And the x that used to be inside the logarithm is now over on the other side. So x is equal to 2 to the 6th. 2 to the 6th is 64. That's a fine answer because my only rule up here at the top was that x had to be greater than or equal to 0. Just greater than, actually. In my next equation, when I look at this, I can see if I were thinking of my domain, in the first part, x would have to be greater than 0. In this one, x could actually be greater than negative 3, but x is greater than 0 sort of covers that. So I just know for this problem, x is going to have to be positive. When I look at the problem, I've got a log, and I have another log. So every term in the problem has a logarithm. When that happens, I want to condense and get my logs together on one side and my logs on the other. So I have the log of 2 things added. That means it's going to be the log of their product. There's no base for these logarithms. They're common logarithms with a base 10. But that's not going to matter. So long as they're the same base, when I go to do the problem, the insides are going to have to be equal if the logs are equal. So I have this x times x plus 3 is going to have to be equal to 4. I'm going to go ahead and distribute on the left to get x squared plus 3x, and that's going to equal 4 on the right. Again, the only reason I could do this is because I had a log on both sides, so the insides were equal. This is a quadratic. To solve a quadratic, I like to get that equal to 0, and then I factor. So this is going to factor into x plus 4 and x minus 1. So my solutions will be x equals negative 4 and x equals positive 1. The negative 4 solution is extraneous because that would make me take the log of a negative number. The log of 1, however, is going to work fine. When I plug it into my first term, I'd have the log of 1. The second term would be the log of 4, which is also fine. All right. In example 4, again, I have things in logs and things not in logs. So I need to get everything not in a log on one side and everything in a log on the other. So I'm going to move the 3 over to the right by subtracting. Then I'm going to divide both sides by 2 to get 7/2. ln is the log base e. Now when I'm ready to convert to exponential form, my base would be e, my exponent would be the 7/2, and then the x is now by itself. E to the 7/2 I know is going to be positive, so it's going to work as a solution because any exponential will always turn positive. No matter what I put in the exponent, nothing can turn e into a negative. All right. You guys can go ahead and try the last one and then check your answer. Remember to look and see, does everything have a log or only some things? And then be sure you check your answers in the end. Pause the video while you give that one a try. So on this one, I condensed my logs on the left. I took my 2 logs and put them together by multiplying the insides. Then I had the log of this stuff on the left equals the log of the things on the right, so I could set the insides equal. I needed to then distribute my x, and it was a quadratic, so I moved the 2 over to the left to get it equal to 0. I factored, and then I solved each factor. I got x is 2 and x is negative 1. When I look back at my original equation, I'm fine plugging in a 2 because that will be log of 2. I'm fine plugging in a 2 into my second log because 2 minus 1 is still positive. There's nothing to plug in my final log. So x equals 2 was a good answer and I circled it. But when I try to plug in x equals negative 1 into my first log, it gives me the log of negative 1, which I'm not allowed to do, so that was an extraneous answer, and I crossed that one out.